I'm recording because we have so many people absent. All right, so here we go. What do I know on A? On example 1, I mean. A is always going to be
90.
Angle A is always 90. Always. It is a tangent that meets a radius. On example 2, I know that angle C plus angle A will always equal what? 131. All right, on number 3, let's see if we can fill in all of the things. How big is angle A and angle B? This was a little trickier. This is a what kind of triangle? It has 2 equal sides. What's that called? Isosceles. That means the A and B have to be the same angle. So I'm not looking at the right angle. I know that there's a right angle where the lines meet, but I'm trying to figure out on that triangle, how big are angles B and C? It's going to be a fraction or a decimal. So what's 180 minus 45 divided by 2? What'd you say? 67.5. Do we agree? Is it 67.5? And then I can figure out that angle A is going to be equal to 180 minus 45, because that's angle X. On number 4, can we figure out an equation for angle B? Think about how many degrees are in a circle.
360.
360. And I know that A is equal to 180 minus 24. So B would be 360 minus 180 minus 24. And when I distribute my negative, I get that angle B is going to be equal to 180 plus 24. So it ends up whatever the angle on the outside, if I do 180 plus that angle, I should get angle B. And on example 5, I have the angle A is going to be equal to 180 minus 163. On one other thing that I want y'all to be aware of is we're going to have the measure of our arc is going to be in degrees, is going to be the same as the central angle. So like right here, this length here is just 163 degrees. So I'll show y'all. Are we good on this slide? Oh wait, 5 more seconds, we good? All right. So like here, if the central angle is 60 degrees, then the external, it's not on the paper, but if you just want to make a note something, if that helps you, or if you feel like, oh, I got it now, it's really 60 degrees, 60 degrees, it's the same. So I just wanted y'all to be aware that 60 degrees for the central angle gives us 60 degrees for the arc, length in degrees. So whatever the central angle is, that gives you the length of your arc in degrees. We'll talk about how to figure out the measure based on the size of the radius next class. Y'all can go ahead and glue in the half sheet into your notes. And then we'll take a look at some vocabulary. Are we ready? So, F. We're looking at point F. What is point F best described as? We're thinking about vocabulary terms. The point where the tangent line touches the circle, that is known as the point of tangents. Number 2. I did not do a good job of printing all the little notation on your screen, so line FE. What is line FE best described as? That touches the circle in one spot, so that's called a tangent line. Line segment HG is best described as a radius. Line DB, it goes through the circle and touches at 2 points, so it's called a what line? Starts with S. Secant line. So all of 3.7B and what you did with Olga's walkie-talkie, those are secant lines because it crosses through the circle and touches in 2 spots. 3.8, where it only touches in 1 spot, those were all tangent lines. C is best described as a, where is it located? The center. So C is a center. All right, line segment DE. It's a diameter. Now, if it's line BE on number 9, line BE is a secant line. So we're just looking at the line segment. The best description for it is a diameter. If we're looking at the whole line, the best description is a secant. Number 7, line segment DB. You're going to have to go all the way back to that peak paper at the start of the year. What is that called? We did a little sort activity with all of our vocab. Remember the blue, yellow, and pink papers? In the circle, vocab was on the pink page, I think. Is that right? Or is it the yellow? The yellow. Sorry, yellow page. Yellow page. What's that called? Line segment DB. Would best be described as a chord. And then line AG is best described as a tangent line. And line segment CA is best described as a radius. So a little vocab for you. Sorry, it's kind of cut off on the screen. I'm going to go back a slide. And can someone read A underneath the table? What does A say? Melanie, can you read A for us?
Take the side of a polygon and all tangents to the circle and the circle radius.
Alright, so this is our example. So does that describe the left or the right? Where all the lines of the polygon are tangent. You see right here we have a point of tangency, and point of tangency. So anytime you have a polygon who all of its sides are tangent, it is called an inscribed circle. That means that the polygon surrounds the circle. So the circle is inside or inscribed. Eric, can you read B for us?
The sides of the polygon are all chords of the circle, and the circle is.
So here we have a chord, and another chord, and another chord. So this is called circumscribed. Which thing about circumference goes around, so it's going around the polygon. Circumscribed. So A was inscribed, B was circumscribed. So that was the vocab, just making sure we're all on the same page when it comes to how do I recognize these things when looking at geometric figures. We're going to do a couple of examples on the front and the back, and then I'm going to let y'all work on your performance task and finish up this. All right. So number 11. In the diagram to the right, MQ and NR are diameters. So let's think about a diameter splits a circle into halves. So how many degrees is it from M to Q? If you split a circle into half, it is 180. And over here, I know that this is 182. So how big is MOR? A 107 degrees. I'll zoom in a little bit. See if that helps. Okay. That means, does anyone see a vertical angle that I could go ahead and also label? Which one? OMON is 73 degrees because it's a vertical angle. And then PQ, how big is PQ going to be? What? I'm looking at this little angle here. How big is this little piece, this little sliver of the pie? 26. There's a couple of ways to get 26 degrees. You can think about it as it makes a vertical angle with 107. So I could do 107 minus 81 gives me 26. I could also say, oh, there's 180 degrees here. So if I do 180 minus 73 minus 81, that leaves me with this sliver of the pie. So a couple of ways to think about it. So I could go ahead and label some of the smaller arcs. So I know that this is 73 from here to here. This one's 81 from here to here. 26 from P to Q. 73 from Q to R. 107 from M to R. So we have our circle arcs labeled. So now we want to find the indicated arc measures. So when it says what's the measure of MN, what is the measure of MN? 73 degrees. Now when you have something like NQR, that tells me that Q has to go in between N and R. So that tells me which direction on the path that I need to go. So I need to go from N towards Q, and then where R is my ending point. So I need to go NQR. How big is NQR? 180. What about, let's do K? PRN is what I want to look at. So go from P to R to N. So P to R to N is how many degrees? What? Should be bigger than that. P to R to N. So it's going to be more than 180. It's the long way around the circle. So let me highlight it for you so you can see. Yes. So it goes P, R to N. So it's everything but this slice right here. You'll see that? So it's going to be 360 minus the 81, which gives us 279 degrees. So that's how you do this section here. Are we starting to track there? So it's adding and subtracting pieces of the pie, thinking about 360 degrees, 180, and going from there. On this one here, we can think about, this is like the example number 3 from your notes, where we have a triangle. So I could say, oh, if that's 65, then this is 65. So how big is my angle here? $50. So if this is 50 degrees from D to E, how big is E to F? $130. Does anyone see a relationship between the number 65 and 130 degrees? $65 compared to 130. Anybody see the relationship between those two numbers? It is twice as big. And that's always the case when you have a two secants that meet here. Opposite of that angle is always going to be twice as big. All right, so y'all are going to work on that one. I would suggest on 13, you might draw some diameters. You'll end up with lots of congruent triangles, 4 congruent triangles. This will be a congruent triangle. That's a congruent triangle, another congruent triangle, another congruent triangle. I might help you out on that one. On 18, I would also draw another diameter. All right. So y'all are going to be working on this. If you are not done with your performance task, I'm going to pass that back to you now.